Hello everyone, this is Amir. I'm gonna solve some integrals for you at the moment, and I have the questions here with me with no answers. There are 8 integrals. I have put them in my Telegram channel, and you can check it out from the description and have them free. So, I wish that I can help you to solve your integrals much easier, and I wish that it will be helpful for you. And yeah, let's start, guys. Well, the first integral is integral of e to the x minus 1 over e to the x plus 1 dx. It's a little weird, but if you would be a little as sharp as a tack, you can easily get that. You need to put an 1 here plus minus 1 to answer it much easier. How? Like this. See, if we do it, we'll have e to the x minus plus 1 over e to the x plus 1 dx. And now what? We have here plus 1 is here. 2 negative 1 becomes negative 2. Yeah, negative 2 integral of dx over e to the x plus 1. So it's great. Why? Because they will cancel out, and we just need to find the answer of it. Okay? They will both cancel each other out. There's only left integral of dx, which is x. Okay? We'll get to it. But here, see the integral of, I call it as I. I'm gonna look for the answer. Dx over e to the x plus 1. Now what? In here, we need to use the U substitution way. How? If I take U as e to the x plus 1 and I differentiate from both sides, du equals to the e to the x dx. And now dx is du over e to the x. And I must transfer this integral from the x word to the u word. How? We know that the e to the x plus 1 is u. So, and dx is du over e to the x. And what is e to the x? If I bring plus 1 over e to the x equals u minus 1. So dx is du over u minus 1. So now here we have instead of dx, we have du over u minus 1. To do it, we have to use partial fractions. How? Let me tell you. If you write it like this, u minus 1, we must write a letter here like a, b, whatever you like. Okay, no problem with that. And we have to find what is b and what is a and what is b. There are several ways. You put two numbers here and you will get to 2 equations, and you find the a and b. But there's another way to find a. You say limit of, you see, yeah, you must bring the denominator, what is in the denominator of a, top here, and u goes to what makes it 0, and it's 0. Yeah, if I call it to 0, it's 0. Okay, so I bring it here, u parentheses u minus 1, and u cancel out, and it's just minus 1. So a is minus 1. Now what? To find b, we must do the same thing for it. Limit of. Now what we're gonna do, we must bring u minus 1 from the denominator, top here, u minus 1 over u parentheses u minus 1. And guess what? U goes to 1. Why? Because if I call it to 0, u is 1. Correct? And they will both cancel out, and b is 1. Yeah? So I'm going to get rid of these because it takes more space. Okay? So now we need to solve the integral of them. Their integral. What is it? Write it here, and then du. You know that the integral of 1 over u is natural logarithm of u, and here we have minus 1 over u, so it is negative natural logarithm of u. What is u? E to the x plus 1, because we need to we need to change it from the u world to the x world. Yeah, u is e to the x plus 1, and it's not necessary to write this. You can use parentheses because it's always positive. Yeah, plus, and the integral of 1 over u minus 1 du is natural logarithm of u minus 1, which is u minus 1 e to the x, and it's always positive. Well, it's my I. Yeah, I write it here for you. We counted it. They both cancelled out, and there's only left integral of dx, which is x minus 2 parentheses negative natural logarithm of e to the x plus 1 plus natural logarithm of e to the x. See guys, I can bring x from here to this place, and you know the laws of logarithm. It's clear and easy. So now we have, and finally we shouldn't forget the c. I will put it at the end. Ex minus plus 2 natural logarithm of e to the x plus 1 minus 2x ln e. And you know that the natural logarithm of e is 1. If you draw its graph, you will see that it's correct. So now we have what? X minus 2x plus 2 natural logarithm of e to the x plus 1. So 2 natural logarithm of a to the x plus 1 minus x, and don't forget the c. It's clear? Let me draw the graph of natural logarithm of x for you. You know that it comes from here like this, yeah, and here is 1. And you know, E is almost 2.7. It's not exact. Yeah? If we E here, yeah, and it is 1. And you know that the natural logarithm of x is graph is inverse of the graph of a to the x. And if you wanna graph it, it will be like this. See? And it is here. 1 e. I'm sorry for the if it's not exact, but it's like this, yeah. Take a look. Have a look, dude. It was a good question, I guess, because it had the idea which you had to guess it, and then U substitution and partial fraction. Also it was easy, but was needed to know. And then the law of natural logarithm. And finally, this is the answer. So let's move to the next one. The next integral is integral of sine of inverse tangent of square root of 1 minus cosine x over 1 plus cosine x dx and square. Yeah, it's right. Okay. You know that what matters is not just the integrating that you do always. Sometimes you need to know some formulas. For example, in here you need to know the formulas of triangular forms. Like here, you know what? We know that cosine square of x is 1 plus cosine 2x over 2, and sine square x 1 minus cosine 2x over 2. But here we have 1 minus cosine x and 1 plus cosine x, which here is 2x. So what we're gonna do is divided everybody of x by 2 to get this. Yeah. So if I bring 2 here, it will be like this: 1 minus cosine x over 1 plus cosine x square root of it is 1 minus cosine x 2 sine square of x over 2 cosine square of x over 2. Yeah, and they will cancel out, and we have 2 cancel out 2, tangent square of x over 2, they will both cancel out each other, tangent of x over 2. So we must write this in lieu of this. So what now? Okay, now we have the integral of sine square inverse tangent of tangent x over 2 dx. We know that the tangent, inverse tangent of tangent whatever is whatever. See, tangent, inverse tangent of tangent theta is theta, but here is x over 2, so it is x over 2. So now we have sine square of, I told you, it's x over 2 dx. We have it here, guys. Sine square of x over 2 is 1 minus cosine x over 2. And I'm gonna bring 1 over 2 behind the integral. So we have 1 minus cosine x dx. And now 1 over 2 parentheses, the integral of 1 dx, x, and cosine x, sine x with the negative, it's the negative of, yeah, and the integral of cosine x is sine x, but the derivative of cosine x is negative sine x, you know it. And finally plus c. So the answer is 1/2 x negative 1/2 sine x plus c. Have a look. It was a good question. Have a look. Have a look. Interesting. So I hope there won't be any mistakes. Okay, let's move to the next one. The third integral of x natural logarithm of x over square root of x squared plus 1. Yeah, dx. Now what should we do? U substitution won't help us. What should we take as a u? It won't help. What else? No partial fraction. Of course not. You need to use integration by parts, which we go by DI method. It's the same as partial fraction. In this way, you must take one part to be differentiated and another part to be integrated, and you must be smart, a little, not too much, you know. You must, if for example, if I take ln x to be integrated, it will be so long and hard, because the integral of natural logarithm of x is another integration of parts, so it makes the integral much harder, so it's not needed. So I differentiate from ln x and integrate the x over square root of x squared plus 1, and don't forget the plus minus. Okay, derivative of ln x is 1 over x, you all know, I'm sure, and the integration of it is square root of x squared plus 1. If you doubt it, you can differentiate from it, and you will see you get this. How? In the down you have 2 square root of x squared plus 1, and don't forget the chain do with 2x here, yeah, and 2 by 2 cancel out, and we have x over square root of x squared plus 1, which is here. So we are correct and it's not wrong. So now, after differentiating and integrating in integration by parts, we must times these and count the integration of this row. Yeah. Okay. First, here we have square root of x squared plus 1 times natural logarithm of x. And now you have to count this dx. Okay, I'll write it for you here. See, if I times this, I get the square root of x squared plus 1 over x dx, and a minus behind. Okay, so this one. In this integral, we must use the U sub. Yeah. If I take it as U, let me write it green. Sad. Okay. U is square root of x squared plus 1, and I must differentiate from both sides du 2. I'm sorry, I must write it here for you. Du 2 square root of x squared plus 1, and the chain do 2x dx. 2 and 2 will cancel each other out, and dx, if I divided everybody by this guy, we have square root of x squared plus 1 over x du. So I multiplied, sorry, not divided, I multiplied everybody by this guy, but the inverse of it, x over x is square root of x squared plus 1, the inverse. So now here we have minus x is square root of x squared plus 1 over x. What is dx? Here, x squared square root of x squared plus 1 over x du. So now what? Okay, here if I square both sides, I have u squared equals x squared plus 1. So if I times this, I get x squared plus 1. So it's u squared du over, and x times x squared, and x squared is here, see, u squared minus 1. Yeah, u squared minus 1. So now I'm gonna write it here for you. Okay guys, this is the same as our first integral, which we added a 1 and a minus 1 to solve it much easier. Now I do the same as the first integral. Oh, come on, man. Okay, now we have u squared minus 1 over u squared minus 1 du, which they will cancel out, and only integral of du. Okay, and plus du, because there's only 1 left, u squared minus 1. It's easy peasy. They will cancel each other out, and it's just u plus, you know guys, that the integral of du dx over, I'm speaking about something else, but it's the same, but in the x world, dx over x squared minus 1, its integral is 1/2 natural logarithm of x minus 1 over x plus 1. So now we have 1/2 natural logarithm of u minus 1 over u plus 1, and we must change it from the u word to the x. Okay, u is x square root of x squared plus 1. So here x squared plus 1 plus 1/2 natural logarithm of square root of x squared plus 1 minus 1 over square root of x squared plus 1 plus 1. Oh, I must write it here. And it's over. Okay? And it had the negative 4. Yeah? I forgot to write it. Negative, 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 negative. And again, here, negative. So, negative square root of x squared plus 1 minus, I write it here, minus 1/2 natural logarithm of square root of x squared plus 1 minus 1 over x squared. Square root of x squared plus 1 plus 1 and finally plus c. Have a look. Have a look. Oh my god. It was a good one. The I method, integration by parts, and then U sub. Finally, we have the answer here. So let's move to the next one. What? Something got. I'm just looking at the questions. There's no answers here. I was just to tell you. The fourth one, integral of x cubed cosine of x squared dx. It's not that much hard, you know. If I take it as u, du equals to 2x dx, and there is a x square, a hidden x square here. If I write it like x times x squared, it will help me too much. How? I'm gonna tell you. U is x squared. We differentiate from both sides. Du is 2x dx, and we have x dx here, so x dx is du over 2. Yeah? Now, and this is u, right? U cosine u, and I told you dx, x is here, which is du over 2, and I bring the 1/2 behind the integral. And now we have to do another DI method, integration by parts. And don't forget the plus minus. And now we must choose one to be integrated and another to be differentiated. Okay? U cosine u. The derivative of u is 1 and 0 again. The integration of cosine u, sine u, and now minus cosine u. Yeah? So, and the plus. And we must times. Okay? So, now what? It's almost done. Yeah? 1/2 u sine u negative negative plus cosine u and plus c, and we must change it from the u to the x. 1/2 u is x squared sine of x squared plus 1/2 of cosine of x squared plus c, and it's done. Have a look. Wasn't much that hard. It was a good one. Well, guys, if it was their places was inverse, x squared, x cube, it could we have to solve it in another way. I will tell you later on. So let's move to the next question. Oh my god. So the fifth integral, the great one, interesting one. Integral of e to 2x sine x dx. Yeah, it's correct. So the only way that we can use here is to use the integration by parts and know that it's a repetitive integral. Repetitive integrals, like it can be triangular ones, like secant cube, cosecant cube, and some other ones. I will tell you about them later, for sure. Okay. Now we should go for DI method. Plus, minus, plus. Okay. So, if I differentiate from e to the 2x and integrate from sine x, here 2e to the 2x, e to the 2x and the chain to 2, and again e to the 2x, 2 multiply 2, 4. And now sine x, integration of sine x is negative cosine and negative sine x. Yeah? And now what? See guys, here you have e to the 2x, e square x, sine x dx. And if I multiply these, and finally I have to check for the integration of this row, and it's the same as this, the variables and everything. And finally I will bring it from here over and divide everybody by the number behind it. So let's see what you'll get. Yeah. So e to the 2x minus cosine, negative e to the 2x cosine x, negative plus 2 e to the 2x sine x. And finally we must find its integral of this row. Yeah, negative here, integral of, and let me bring the 4 behind the integral, e to the 2x sine x dx. Yeah, if I bring it here, 4 and 1, let me write it for you. Okay, 2x sine x dx, and 4 with 1, 5, equals negative e to the 2x cosine x plus 2 times e to the 2x sine x. Yeah, and we have to divide everybody by 5. Now we have our answer, integral of e to the 2x sine x dx equals 2 over 5 e to the 2x sine x, negative 1/5 e to the 2x cosine x. And don't forget the plus c. You can add c whenever you want, and it doesn't matter if I wrote it here, it was c1 over 5, and we could write it c. Doesn't matter. Yeah? Have a look, and we call them repetitive integrals. I will talk with you about them later. Yes, that's it. Have a look. Okay, let's move to the next one. The 16, which one? The 5th one, yeah. Oh, sorry, 6th one. Integral of e to the square root of x, vx. Okay. If we didn't have the square root, it was so easy, and the answer was a to the x plus c. But now, when it's the square root of x, we must take it as u and use the U substitution. Yeah? Okay. U equals square root of x. We must differentiate from both sides du to square root of x, and the chain rule is 1 dx. So dx, if I multiply everybody by this guy, I mean this 2 square root of x du, and we know that the square root of x is u, so dx is 2u du. Now here we have integral of dx is 2u du. I prefer to bring u to behind the integral and u e to the u du. Oh guys, another integration by parts. It's so useful. You see, everywhere you're using it. But of course, there are integrals which this method won't help us, but it's so great the way, I mean. Okay, so di. I select u to be differentiated and e to the u to be integrated, and don't forget plus minus derivative of u1 and 1 0 e to the u to infinite e to the u. Okay, and now we must times them, u times the u. Okay, so 2 parentheses e times e to the u minus e to the u plus c. So we must bring it from the u to the x word. Okay, let me write it with blue. It's blue. 2u. U is x is square root of x. E to the square root of x minus 2 e to the square root of x and plus c, and this is the answer. Have a look, have a look. It was a good one. U substitution and di method. It's 40 minutes. Nice job. Oh, let's go to the next one. Can I write it here? I don't know, I'm not sure. Oh, let's clear it. Well, the 7th integral dx over x times x to the 5th power minus 1. Yeah. So what I'm going to do here is an interesting idea. I'm gonna factor from x to the fifth power from this fraction. See, dx x times x to the fifth power 1 minus x to the negative fifth power. Yeah, it's the same as this if I multiply it to this x to the fifth power and negative 1. So now what I'm gonna do is x times x to the fifth power is x to the sixth power, and I bring it top to the top integral of x to this negative sixth power over 1 minus x to negative fifth power dx. And now we should use the U substitution. I call it as U. Let me write it here. U equals 1 minus x to the negative fifth power. And we differentiate from both sides. Du equals, it comes here and minus 1. 5x to the negative sixth power and dx. And see what? X to the negative sixth power dx is here. And if I divided everybody by 5, it will be du over 5. Yeah? So this one is du over 5. And this guy is u. So here we have du. I bring 5 behind the integral. I'm easy. It's better for me, okay? And this one u. So and you know the integral of du over u is natural logarithm of u. 1/5 natural logarithm of u plus c. And what is u? Natural logarithm of 1 minus this, it was u, plus c. And you can write it more, but like this. See, 1/5 natural logarithm of x to the fifth power minus 1 over x to the fifth power plus c. This is the final answer. Have a look. Have a look. And let's go to the final one. I wish that I can manage more integrals for you, and even maybe another subjects like limitations, DPE, differential partial equations. Yeah, maybe another subjects. Why not? It will be awesome. So the next and the final, last not the least. Okay, eighth one dx over 1 plus x squared squared. What should I do? The integration by parts won't help. U substitution might help, but there is a better selection than that, which is triangular U substitution. If I take x as tangent theta, and 1 plus tangent theta square is secant theta. And let me write it for you. X equals tangent theta. Differentiate from both sides. Dx is secant square theta d theta. Yeah? Now, here, 1 plus tangent squared theta squared. Now, dx secant square of theta d theta. You know that it is secant squared theta. Now we have secant squared theta d theta over, and secant squared theta square will secant the fourth power theta d theta, and they will cancel each other out. Here 2 power 2, yeah. And you know that the d theta over secant squared theta, I'm sorry, it's cosine squared theta d theta, okay. And we know that cosine squared theta is 1 plus cosine 2 theta over 2. I blinked 1/2 behind the integral. 1/2 1 plus cosine 2 theta d theta. So look at here, I didn't look at it. Okay, now 1/2 the integral of 1 theta plus cosine 2 theta. 1/2 sine of 2 theta plus c. Okay, you know that you can write in lieu of sine 2 theta 2 sine theta cosine theta. This way 2 and 2 will cancel each other out. Let me put them here. Okay, now I must find what is theta and what is sine theta and what is cosine theta. To find theta, here we just need to take the inverse tangent from both sides. Theta is inverse tangent of x is. And for finding sine theta and cosine theta, we just need to draw the right triangle. Theta and x1, and here we have x squared plus square root of x squared plus 1. So here sine theta is x over square root of x squared plus 1, and cosine theta, the adjacent over this one, this guy, 1 over square root of x squared plus 1. So it's almost done. Now 1/2 theta, what is theta? Inverse tangent of x plus sine theta 1/2, yeah, 1/2, they cancel each other out. 1/2 sine theta x over square root of x squared plus 1 times 1 over square root of x squared plus 1 plus c. Now 1/2 inverse tangent of x plus 1/2 x, this times is x squared plus 1 plus c. This is the final answer. Have a look, it was not that much hard. You just need to know that take x as tangent theta, and the rest is easy for you. Have a look. Well, hopefully it's done, and I wish it would help you and be useful for you. Although they were not that much hard and challenging, and I'm planning to have more integrals, hard ones and great ones with intelligent ideas, and not just the integrals. I told you limitations, series, uh, PDEs, whatever. So it's done, and have a great time. Goodbye for now. See you again, guys.